Hello students, welcome to today's class on the topic set theory. Myself Avinash and I'm your maths faculty. I hope in this physics for our Nexus batch, maths classes are already started, right? So you have 2 or 3 classes on basic math taken by Kundan sir, right? So the next topic, that is the next concept, that is about set theory, I will be dealing with that. And after a few classes, again Kundan sir and again me, okay? Both of us will share the topics, right? So today in set theory, we are going to discuss about sets and their representations, types of sets, operations and complement of a set. So now you may ask me, sir, what is a set actually? Where are we using, or how are they useful? Right, students. In general, in every chapter of mathematics, you have questions, and at the end, you need to write the answers for that. You need to give the solutions, right? Just in case if you have only one value, let's say x equal to 1 is your final answer. It is okay, you can directly write x equal to 1. But not every time we'll be having a single answer, or not a number always, right? So we have to represent our solutions in particular method, right, in a well-defined manner, right? So that is a concept where we'll be using this set theory. Okay, so the representation, what I'm saying, representation, so that is very useful in representing a solution in every chapter. I can say in every chapter, not just in this chapter, right? So we'll be dealing with representations, we'll be dealing with intervals. For example, I have a range of numbers, so I want to write that mathematically, right? So that is where we will be using the concept of set theory. Fine. So first of all, what is a set? From where this set topic has been invented or discovered or started, right? So he's a person, right? He's a mathematician named Georg Cantor. Okay. So he was a German mathematician, and he started with what is a set? What is a set? Because while he was doing his research and all, ultimately he's always stuck at giving the solutions. Because, okay, he got the solution, but how to represent that? Sometimes he may have a lot of answers. He cannot sit and write all the answers, right? So that's the reason the mathematician has invented a new topic, that is a branch that is called a set. So, what is it? A set is a well-defined collection of objects. A set is a well-defined collection of objects. What do you mean by well-defined? So, when I say well-defined, the answer of any question should be same for everyone. The answer should be same for everyone, right? For example, I ask you, what is your name? It's the same. It's a unique name of yours, right? Okay, I'll ask you, what is the capital of India? It is a unique name. But if I ask you, make a list of top 5 students in the class. Top 5 students. Top 5 students means, how are you going to judge the top? Like, is it along with the complete overall marks, or subject-wise marks, or in some other categories, right? So, answer for this question is not the same for everyone. Answer for this question is not the same for everyone, correct? So that is where we are saying well-defined. When I say well-defined, answer should be unique for all, right? But this question has random answers, right? So is it a well-defined collection? No, this is not a well-defined collection, and so we cannot say it is a set. Right? So, what more examples I can judge? What more examples I can give you about set? Okay? And what are the ways of representing on all those? We'll look into that. Okay? See here. Sets are denoted by capital letters and elements are denoted by small letters. Sets are represented with capital letters like capital A, capital B, capital C, right? Capital A, B, C, or D, X, Y, Z, whatever it is. But in general, we represent a set with capital letters. Write down the set of all natural numbers. Simple question. Write down the set of all natural numbers. So when I say natural numbers, without any doubt, everyone will give the same answer. Maybe the order may be different, but ultimately your answer should look like this, right? Starting from 1 and goes to infinity. So it is fixed. So this is called a well-defined set of numbers or well-defined collection of objects, right? So if you can see here in the notation what I use now, I used capital N here, right? Capital N, that is what I'm saying. Sets are always denoted by capital letters, right? And the elements, if at all they are not the numbers, we denote by small letters. That means we can say A1, A2, A3, or we say A is equal to, like it has the elements A, B, C. The set A has the elements A, B, C, but this is still not the complete representation. We need to use brackets like this. We need to use braces like this. We will see in the next slide. Okay, so this is a basic representation of a set. Basic representation, or we can say notation of a set, right? If A is an element, see, A is an element, so I can say A belongs to, this symbol is belongs to, okay, this symbol is used to belongs to. So I can say the small a is belongs to capital A, B belongs to capital B, C belongs to capital C, right? But here I'm only mentioning about set A. So B belongs to set A and C belongs to set A. All those in the same set. Okay, B and C are different sets. We're not taking here. So A, B, C are always lying in the same set. Here it is A. Right. And if A is not an element, then we say A does not belong to. This symbol is used for does not belong to. What is that? Does not belong to. Okay. So we belongs to and not belongs to. We have discussed two notations here. Okay. So now we will move forward. Let's see what all things we are having in this. Okay. Set of all natural numbers, the same example I gave you before, right? So yes, this is a well-defined collection of objects. Okay. So you know n is equal to all the natural numbers 1, 2, 3 and so on. Set of all integers from 0, 1, 2, 3 as well as negative, minus 1, minus 2, minus 3. All these are integers, right? And Q is set of all rational numbers. Q is set of all rational numbers. When I say rational, okay, you should be very careful. Like every rational number will come, not just in between some numbers, not just 1, 2, minus 1, minus 2, 1 by 2, 1 by 3. Every rational number will be there. So how many elements are there in this? Infinite elements, right? So that is also very important. How many elements are there? Based on that also we will be defining different types of sets in the coming slides. Okay. So till now whatever we discussed is about the set, the basic definition of a set. Okay. And now we are going to representation of a set. How to represent a set. Okay. So there are two methods of representing. One is a roster form, or we can say tabular form. The next one is a set builder form. Okay, students. So roster or tabular form, and the second one set builder form. So what are these two methods? These two methods are two different methods of representing a set. Okay, we got the final answer and we want to represent that in some manner, right? So for that we have mainly two methods. There are still one or two more other methods also which we are not going to cover. These are the two main methods, right? So first let's try to discuss about roster form or tabular form. Okay, so see what is there on the screen. In roster form, all the elements of a set are listed. The elements are being separated by commas and are enclosed within braces. Once again, okay, all the elements of set are listed. That means we can see, we can directly see what are the elements in that. We can directly see what are the elements. For example, the same natural number set, it has 1, 2, 3, 4 and so on, right? The elements are being separated by commas. You can say comma, 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 right? The elements are separated by commas and are enclosed with braces. Right? So you can see these are the braces, okay? So these are the flower brackets we can say, okay? Some people say braces, flower brackets, flower braces, whatever it is, okay? So this type of representing is called a roster form. Directly, the elements will be there in that, nothing else, okay? Directly the elements will be there in that. Set of all natural numbers which divide 16. So I want to write this in roster form or tabular form. So what are the numbers that divide 16? what are all the natural numbers I'm talking about. Okay, don't worry about all the integers and all the negative numbers. Right? Set of all natural numbers which divide 60. So you can say the factors. Okay, so the factors of 60 you can say 2 into 15, right? So 2 into 30. Right, 2 into 30, even 1 into 60. 1 into 60 will also come. Okay, so 1 into 60, 2 into 30, so 3 into 10, 3 into 20, 1 to 60, 2 30s, 3 20s, and 4 15s. 4 15s. Anything else with 5? Yes, 5 12s. 5 12s, okay, 5 into 12. Next, with 6, 6 10s, right? 6 into 10, good. With 7, no. With 8, with 8, no. 9, no. 10, okay. So that's all, we got all the values. So answer for this is written in brackets or braces, okay. And all the numbers, all the natural numbers, so I can include 1, 2, 3, 4, 5, 6, right? Still, these are also the numbers. So 10, 12, 15. So 10, 12, 15, 20, 30, and 60. All these are in the same set. Okay, so let us write, we can write it as A. A is equal to all this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are total 12 elements inside that. Okay, I can say you here, the number 3 belongs to A. That symbol belongs to 3 belongs to A. 6 belongs to A, right? But if I say 7, what is that I can use here? 7. 7 does not belong to A. Right, students? Are you all understanding? Okay, we have a lot of applications, don't worry. We have lots of applications. We will clear everything in those applications, okay? Right. Let's move forward. Students, I hope you are following Physics Wala app as well as YouTube sessions, right? In Physics Wala app, you can find all these notes, all the videos, and DBBs will also be provided, exams will also be provided in that. So don't forget to open Physics Wala app and go to this particular batch, that is a Nexus English batch, okay? Right. So the next one, in set builder form, what we're going to do. Till now, in tabular form or in roster form, we directly listed what are all the elements, right? By seeing, we can say, yes, these are the elements. But here, when we are moving to set builder form, the name itself says that set builder form, we need to build up. We need to build up the set. Build up means, so the set representation is not direct. We need to bring it up, okay? So in set builder form, all the elements of a set possess a single common property. So all those elements will have a single common property, okay, which will be given or which we need to frame according to the questions, okay? For example, I have here, x is a natural number and 13 less than x less than 20. You can see here, x is a natural number and 13 less than x less than 20. Okay, people, I'm seeing your YouTube comments and all. I'm very happy that you're really enjoying the sessions, everyone, right? So in the last class, Kundan sir's class you have enjoyed, and I saw your comments that you have asked me for the topic of set, so that's the reason we started, okay? Right. So, x is a natural number and 13 less than x less than 20. So, less than, when I have just less than, we should not include 13. Here also we should not include 20. But we need to write all natural numbers between these two. We need to write all the natural numbers between these two, right? So, I can say A is equal to 13. Can I include 13? No. I should start with 14. I should start with 14, okay? So, 14, 15, 16, 17, 18, 19. But what about 20 now? What about the number 20? Can we include 20? No. Because it is just less than, it is not less than or equal to, okay? If the question is equality is also provided, then 13 as well as 20 will also be included. Less than or equal to, less than or equal to, like that, okay? We will see, we have a separate slide for intervals. In that intervals, we will be looking into this type of cases, okay? Don't worry about that, okay? So, what is the next one that we can go for? Write the solution set of the equation x square plus x minus 2 equal to 0 in roster form. So, we need to write the solution of this in roster form, okay? So, we will try to solve this question first of all. It's a quadratic. I hope you already know what is the formula used for quadratic. Even though if formula is not there, we'll try to factorize it. Okay, it's a simple question. Okay, so please do it fast and tell me your answers in the comments, everyone. Okay, so I think you know how to factorize. Okay, so x square, we have plus x and we have here minus 2. So minus 2 means minus 2 into 1, right? 2 into minus 1 we can do. So we can go with plus 2x minus x minus 2 is equal to 0. Okay, so I hope you already know how to factorize this, how to split that middle term. Here it is 2 or minus 2. So minus 2 we are writing as a multiples of 2 into minus 1. Why 2 into minus 1? Because we need to have plus x. So 2x and minus x will give you plus x. Okay, so if you take common, you will get x into x plus 2. And here we will take minus 1 common. You will get x plus 2 is equal to 0. So we will get x plus 2 into x minus 1 is equal to 0. Right? X plus 2 into x minus 1 is equal to 0. So I can equate this to bring x plus 2 is equal to 0. That means x is equal to minus 2. Or x minus 1 is equal to 0. So I can say x is equal to 1. So we have two values. I have two values. Okay. Write the solution in roster form. Roster form is directly listing out the numbers, right? So I can write, for example, a is equal directly the numbers minus 2 and 1. Minus 2 and 1. But what if I want to write the same thing in set builder form? So there should be some pattern, right? Because x should be a solution of x square plus x minus 2 equal to 0. So in that case, what I'll write as a is equal to, carefully see, I'm writing the same answer in set builder form as well. A is equal to, I write x such that, or you can take any other number, right? X such that, we want to find the numbers x, such that x is a solution of the equation, x is a solution of the equation x square plus x minus 2 is equal to 0. X such that, this two symbols, two dots is such that. We need to write all the answers of x such that x is a solution of x square plus x minus 2 is equal to 0. That is set builder form. This is a roster form. It's a very simple concept. Okay, very, very simple concept. I don't think much workout on that is required. So write a is equal to 1, 4, 9, 16, 25 and so on in the set builder form. Now we need to write in the set builder form. So how are we supposed to write? Again, the same thing. So let us take a is equal to, if you carefully observe the pattern of the numbers, it is 1, 4, 9, 16. All these are squares. All these are squares, right? So squares of natural numbers. Why only natural numbers? Because 0 is not there. If 0 is there, I need to include squares of whole numbers. Right? So these are only squares of all natural numbers, not even integers. If we again talk about integers, the negative value should also be counted. Okay. So I need to write in set builder form. The given thing is roster form. Can you see that? The given thing is in roster form. I need to write set builder form. So a is equal to, I want to write x such that, I want to write out all the elements of x such that x is a square of natural numbers. Square of natural numbers, right? X is a square of natural numbers. You can write like this, simple word. X says that x is a square of natural numbers. All natural numbers, okay? When I'm not giving any particular interval, we take all the natural numbers, right? So there is not just one set builder form. You can write in so many ways. Okay, you write it in some other format, but still that particular value should be equal to this one. Okay, so if you can try to write like that, that is also correct. It's not only x here. You can write y, you can write a, whatever it is, but the ultimate answer should be the same. Okay. Next one, write 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6 in set builder form. So now careful observe. Okay. 1 by 2, 2 by 3, 3 by 4. Okay, fine, it's moving. But is it till infinity? Is it going till infinity? No. It is going only till 5 numbers. So we need to be very careful now. We need to be very careful with the numbers and as well as the formula behind that. Okay, so I'll write that a is equal to, in set builder form, a is equal to, I want to write all the elements of x such that these two dots gives me the value such that, okay, it gives the word phrase such that x such that x is equal to n by n plus 1. What is this? N by n plus 1. Why I'm writing like this? 1 by 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. 5 plus 1 is 6. N plus 1 is n plus 1. So that is the basic format this is moving. This is following. Right? So n by n plus 1. You can see x is that x is equal to n by n plus 1 and n is a natural number, that's okay, right? N belongs to natural numbers, that is also okay. But till where we need to go? I need to start at 1 and I need to end at 5. I need to mention that end point as well. If that end point is not mentioned, we just go on like that, which should not happen. Okay, so n belongs to natural number and n less than or equal to 5. N less than or equal to 5. So here if you observe, I didn't mention this 1. I didn't mention the starting value. Why? Even you mention that's not a problem. But here I didn't intentionally miss that because it is already self-explanatory that n is a natural number. It is already self-explanatory that n is a natural number. So by default, n will start with 1. No choice for that. Okay. So even if you mention that or if you don't mention that, that's not an issue. Fine. So what is the next one? So let A is equal to 1, 2, 3, 4, 5, 6. Insert the appropriate symbol belongs to or does not belongs to in the blank space. Okay. So here we have 6. I'm doing the first, third and fifth. The remaining you can do it later as a homework. Okay. It's a very simple thing. 5. Just tell me 5. Is it a number in the set A? Is 5 a number in set A? Yes, it is there. So what I can say 5 belongs to set A. I can say 5 belongs to set A. What about 0? 0 is not there in that. So I can say 0 does not belong to set A. 0 does not belong to set A. What about 2? 2 is again belongs to set A. 2 is again belonging to set A. Simple, very straightforward. Understand? I just have the set and I have the elements. If that element is inside the set, belongs to. If it is not, does not belong to. Right? Very easy thing. Okay. So write the following sets in the roster form. Again, you have 3. I'll be going with first and third. The second you can try that later. Okay. So A is equal to x such that x is an integer and minus 3 less than or equal to x less than 7. I need to write this in roster form. Roster form means we need to list out the elements. We need to list out the numbers, right? So I can write A is equal to, so tell me what are all the elements that I can bring between minus 3 to 7 as well as they are integers, not whatever numbers you want, okay? Don't take all the rational, irrational, no, integers. So it starts with minus 3. Can I include minus 3? Yes, we can include. Why? Because there is a less than or equal to. Less than or equal to. So minus 3 can be included. So the next we can include minus 2. Next we can include minus 1. Next 0. Yes, 0 is also an integer. Don't miss that. Many of them confused at 0 only or at negative numbers. Don't get confused, people. Okay. Minus 3, minus 2, minus 1, 0. And we can go till 7. So don't stop there. Come on. 1, 2, 3, 4, 5, 6. And what about 7? What about 7? 7 can be included, yes or no? No. Why? Because it is just less than 7. So you should not include 7 in that. Okay. Next one. Third question. Okay. B, I'm leaving that for you. Natural number less than 6. Straightforward. Very simple question. See. X is a 2-digit natural number such that the sum of its digits is 8. So I want to write all the 2-digit numbers such that the sum of the digits is 8. What do you mean by sum of the digits? For example, I have 24. 2 plus 4. 2 plus 4 is 6. 2 plus 4 is 6, right? So that is what? Sum of the numbers. Okay. So tell me what are all the numbers that will come here? What are all the numbers that will come here? Okay. So 11, 12, 13, 14, 15, 16, 17, I think 17, we can start with 17. We can start with 17, right? Okay. Next, Next, 1 plus 7 will give you 8. In the same way, 2 plus 6 will give you 8, so 26. 3 plus 5 will give you 8, 35. 44, 44, 53, 62, 71, 71, right? 71. Then next, 80. 8 plus 0 is 80. That don't miss that. Don't miss that. 80. And then whatever after that. I don't think after that we'll get any other number that gives you the sum as 8. Okay, so 81, 82, 83, and all of the numbers will be greater than 8. I mean, greater than 8. So 84, 85, so all those will give you double digit numbers. So we'll stop it there. Okay, so these are the numbers which will give you the sum of its digits as 8. Okay, so simple thing. Let's move forward then, students. I hope you're all following this, right? Write the following sets in roster form again. So it's the same continuation of that previous question. So I'll take one of that. I'll take the fifth one. The remaining you can take it as work for later. See, these are very simple questions. Don't think that I'm giving you a lot of homework. No, just 1 minute, not even 1 minute you can complete that. Okay, that's the reason I'm giving you as many as applications as I can so that you get exposure to all these different questions in this class only. Right? Okay. Next one, fifth. The set of all letters in the word trigonometry. So now there is a small confusion people will ask. Sir, we are having trigonometry T repeated twice, R repeated twice, O repeated twice. So what we are going to do with this repeated letters? Students, in a set, even though the numbers or the letters or the elements gets repeated, no need to worry, just include once. Just include only once, no need to write it all the times, okay? So that is E is equal to, I'm talking about a trigonometry. So E is equal to, I can start with T, then R, I, G, O, N, O is already listed here, M, E, T is already written here, R is already written here, so Y. So these are the letters. Careful observe, there are no repetition, right? T, R, I, G, O, N, M, E, Y. So these are the letters of the word trigonometry, which is set E. Okay. Set fourth one is prime number, which is divisor of 60. And next one, set of all letters in the word better. Okay. So same thing, we can do that. Divisor of 60, the same thing, but here is a prime number. Don't forget that. Not all the divisors you need to consider. You just need to consider only the prime numbers. Okay. So what next? Write the following in set builder form. So now this is important. Till now, writing in the roster form is very simple. Writing in the roster form is very simple, but now we need to go for set builder form. Okay. So here, 3, 6, 9, 12. How to write that? Just by seeing, you can say that they are the multiples of 3. They are the multiples of 3. So I can write, let us say the set as A. A is equal to elements of X such that X is a multiple of 3. So I'm writing it as 3n. X is equal to 3n. So X is a multiple of 3. But can I write all the multiples? No, I need to stop at 12. I need to stop at 12, right? So n is less than or equal to 4 because this 3 into 4 is 12. 3 into 4 is 12. So n less than or equal to 4, I need to stop it there. If I don't mention this n is less than or equal to 4, I need to write more numbers. Next 3 multiples 15, 18, 21, 24. No. As I shouldn't write all those, I need to stop it at this n less than or equal to 4. The same thing, next question. You can do that. Multiples of 2, right? 2, 4, 8, 6, 9, 2. Same 2n. And we have 5 elements. Next is 5 multiples. Is it 5 multiples? Careful observe the third one. Careful observe the third one. Is it 5 multiples? No. These are multiples of 5, but this is 5 square, this is 5 cube, this is 5 power 4. So what I can write? I can write C is equal to X such that X is equal to 5 power n. I can write X is equal to 5 power n because 5 square, this is 5 cube, this is 5 power 4. So n less than or equal to 4 again, okay? N is a natural number. I didn't mention that, right? Students, he had mentioned that N belongs to natural numbers, okay? And here also write N belongs to natural numbers. Again, if I don't write natural numbers, you can still go with the negative numbers as well, okay? So, starting as well as ending should be listed inside that, okay? So, 2, 4, 6, all the even numbers, you can write the same thing. All the positive even numbers, right? 1, 4, 9, all the squares. People, no need to write like this, friends. No need to write like this, x equal to 3 and x equal to 5. And you can directly write in terms of words also. Set builder form has not just one answer. You can write as many formats as you want. You can write in as many formats as you want, okay? So that's not at all an issue. So the next one, so once again, list all the elements. X is an odd natural number. Odd natural number starts with 1 if I'm not wrong. 1 is also an odd number. 1 is also a natural number. So 1, 3, 5, 7, 9, and so on. So all these are odd natural numbers, right? Next one. Next one. What is the next one? X is an integer. Minus 1 by 2 less than x less than 9 by 2. Integer. So minus 1 by 2 means the first integer I can start with is 0. Then 1, 2, 3, 4. 9 by 2 is 4.5. 9 by 2 is 4.5. So you need to stop it at 4, right? Please correct me if there are any mistakes. Okay, it's quite easy that I might have missed some numbers. Okay, it might happen. X is an integer and x square less than or equal to 4. X square less than or equal to 4. I'm giving you this as a homework. Just count that, where 0 will satisfy 1, 2, minus 1, minus 2, 3, minus 3, 4, minus 4. Are they satisfying this in equation? Yes or no? Whatever numbers are satisfying, just write down. Okay, so simple question, right? So few more questions as your homework, people. So X is a letter of the word loyal. The same. X is a letter, okay? And X is a month of the year not having 31 days. List all the elements. Just list all the elements. Okay. So what is the previous thing? Okay, we are writing a list only. So listing in the sense it is in the roster form. Okay. X is a consonant in the English alphabet which precedes K. Precedes means before. So before K, what are all the consonants you are getting? So you need to list all those. Okay. X is a month of year not having 31 days. Okay, so you know which all months have 31 days, which months have 30, which month has 28 or 29 days, right? So list all those numbers, okay? Okay, so the next one, okay. So the next one is about types of sets. What do you mean by this types of sets? Okay, till now we just discussed what is a representation, but sometimes we may have just only one element in the set. Sometimes 10, 15 elements, sometimes infinite elements, sometimes no elements at all. Yes, no element set is also possible. No element set is also possible, right? So, based on the elements or based on the properties that it is exhibiting, we have different classification of sets. Okay, so in the types of sets, the first one we're going to discuss is an empty set. In the types of set, the first one we're going to discuss is an empty set. Students, I hope you all are following. Till now, the first part, what we have discussed for the first half an hour, is just a representation of a set in roster form and set builder form. I have taken a lot of time for that, almost 30 minutes, just to introduce the representation of a set. The reason is, the rest of the chapter you should not be confused when I'm writing that in the roster or set builder form. Okay, 99% will be using only roster form unless and until it is asked to write in set builder form. Okay, right. So a set which does not contain any element, called the empty set or null set or void set. Okay, null set or void set or empty set, everything is the same. So that means it should not have any elements. So you may ask me, sir, when there are no elements in the set, why to write down? Why to mention this type of set? People, sometimes when you are solving mathematical equations, you might have encountered no solution. No solution case, right? Then how to write that answer? So we need to have some representation even for that mathematically, right? So that is where we will bring the concept of empty set. So empty set means just we represent with this symbol. Okay, this symbol is called phi. This symbol is called phi. Phi, okay, or F5, whatever you want. Okay, sci-fi you say, right? Sci-fi movies. So phi, and this is just empty braces. Why empty braces? See, braces itself define a set. The elements inside that are the elements in the set. Now I told you that it is an empty set. There are no elements inside it, so you shouldn't write anything. Often people get confused this one with this type of representation. This and this phi as well as this empty braces are equal, both of the same notation, but that is completely different. Students, this is completely different because this is not an empty set. It has an element phi. Just like element A, just like element B, it has an element phi. It has one element inside that. It has a one element inside that, okay? So, I have an example. Between 1 less than x less than 2, okay? X such that x is a number between 1 and 2, and x is a natural number. So, now tell me, which natural number is there between 1 and 2? Is there any answer for that? No. There is no answer for x is a natural number, so I write a is equal to phi, or I can also write as empty braces like this, which gives that there is no solution. There is no value of x satisfying that set. There is no value of x satisfying that set, okay? No value of x satisfying that set, so that is called empty set. Straightforward, simple thing. The next one we're going to discuss is one more example we have. X square minus 2 equal to 0, where x is a rational number. So just check whether it is an empty set or not. X is an even prime greater than 2. X is an even prime greater than 2. People, give your answers in the comment section. Definitely I'll be looking into each and every comment, and again I'll come back to the classes taking your comments back. If they are wrong, I will let you know what is the correct answer, okay? But don't forget to comment your answers in the section, okay? Right. X is an even prime greater than 2. People, I'm not going to comment anything, but just understand what do you mean by even prime. An even number, which is also prime number, you know that it's a very unique case, right? So with that, that answer will follow. So the next one. In the types of sets, we still have finite and infinite sets. The name itself says that. Finite set, I'm not going to give you any definition for that. It's a very simple thing. Finite set means there are finite number of elements in the set. Okay, there are finite number of elements. So what do you mean by finite number of elements? It may have one element, it may have two elements, 10 elements, 1,000, 1 crore, 10 crores, whatever it is. But we can able to list how many numbers are there. List how many numbers are there in that. How many elements are there in that, okay? For example, I say all the natural numbers from 1 to, let's say 1 crore. You may have 1 crore numbers, but it is a finite set. Although it is a very large set, but still you can tell how many elements are there in that. So that is the reason it is called finite set. Infinite set, the name itself says that there are infinite number of elements. There are infinite number of elements. I say, for example, set of all natural numbers. Set of all natural numbers. So now you tell me whether this is a finite or infinite. Good that you will start with 1. You will start with 2. You will start next with 3, then with 4, so on, so on. So what is the ending point of that? Is there any ending point for this? Is there any ending point for this? No. Why? Because it is a natural number. It just goes till infinite elements. We cannot stop. Okay, I may say that 10 crores is the largest number I ever saw. Some other person will come, say 10 crores plus 1. Next person will come, plus 1 for that. Next person will come, plus 1 for that. So there is no n for this number. So such type of sets are called infinite sets. So in this set, we'll be having infinite number of elements. Infinite number of elements, right? Is empty set a finite set? That is the most ambiguous question. Many of them say yes, sometimes no, sometimes yes, sometimes no. People, empty set, you know that it has no elements or zero number of elements. So I can define, yes, I have only this many number of elements. I can define that, right? So that's the reason empty set will fall under finite set. Yes, it is a finite set. Empty set is a finite set. No issues in that. No worries in that, okay? Right. People, I hope you all understand this. And some people have commented whether these are for CBSE or I mean class 11 boards, or are they also useful for mains? People, I'm telling you, CBSE and boards have the boards as well as JEE or other competitive examination has the same syllabus. No change in the syllabus. Maybe one or two subtopics here and there may be different, but 99% of the syllabus is the same. So what makes the JEE exam more tougher is the level of questions, not the concepts. Level of questions. So you can able to do higher level of questions only if you are clear with the basics. Only if you are clear with the basics. That's the reason I'm focusing more time here on basics so that you'll understand with a lot of examples. But moving on further, students, moving on further, class by class, basics I will explain. Along with that, the level of problems will gradually increase. I don't say this is an IIT-JEE question. I don't say that. It may or may not come, but that's not that type of examination where this particular small examples, so small questions will be given. But slowly, day by day, the level of the questions will increase, and in a span of, let's say, 10-15 days after, if you see the lectures, you will really feel the depth of questions. Slowly, gradually, we will be increasing that, okay? And never get demotivated looking at a very big or very confusing question or confusing topic, people. Nothing is there. If you're confused, spend time on that. Spend time again and again. But most of them, what you do, when you feel that some concept is not clear, you avoid that. I saw many students getting avoided. They avoid the topics which they are not comfortable, people. That's okay at the end of 2 years. Out of, let's say 30 chapters in mathematics, one chapter inside that some subtopics, if you're not clear, okay, at that time, even I say that, forget it about that, concentrate on the remaining topics. But at this point, if you're not clear with this particular concept, and if you say, sir, I don't know this and I want to leave that, that's not at all a correct thing. Because you're in the initial stages, students, you need to learn each and everything. Everything you need to focus, everything you need to learn, and don't avoid anything. Because at this stage, if you are avoiding something, that gets a habit. Slowly, topic by topic, out of, let's say, 100 topics, without your knowledge, you'll be losing more than half of the concepts. That should not be there. Right? So never think that you can skip few topics. No. At this point, at least for the next 1.5 years, you're not supposed to leave anything. Before the examinations of your final JEE, if you're not clear with anything, at that particular time, don't get panicked at that time. If you're really not uncomfortable, leave it and concentrate on the other things, but not now, okay? Right. So we have few more examples. I'm leaving that for you, right? One or two I'll tell you. So state which of the following sets are finite or infinite. X such that X belongs to natural number and X minus 1 and X minus 2 is equal to 0. So what are all the numbers that satisfy this equation? Just 1 and 2. Only 2 elements are there in that. So yes, I can define how many elements are there. So it is a finite set. It is a finite set. I know how many elements are there. Okay. Next, X belongs to natural number and X is odd. Odd natural number. 1, 3, 5, 7. So where do you stop that? Never. You don't know where to stop. It has infinite elements in that, right? So this particular set is called infinite set. The remaining things you can try it on your own. Okay, so if it has no elements, you can also say it's finite as well as an empty set, right? And if it has infinite, you need to tell that as infinite set. Next, given two sets A and B, so now we are going to discuss about equal sets. So what do you mean by equal sets? Equal. When I say the weights of two things are equal, so 1 kg, this 1 kg. So you are measuring the weight of that, right? But what is our parameter to define the sets are equal? There should be some other concept, right? So that is nothing but all the elements of A and B should be identical. Okay, their arrangement may be different, their arrangement of numbers may be different, the arrangement of elements may be different, but the same elements should be there in both A and B. Okay, so if every element of A is also an element of B, every element of A is also an element of B, and if every element of B is also an element of A, that means all the elements of A should be there in B, all the elements of B should be then in A, right? A simple thing. So that type of sets we say as equal sets. That type of sets we say as equal sets. Okay, so you can see A is equal to 1, 2, 3, 4 and B is equal to 3, 1, 2, 4. So although the arrangements are different, right? Elements are same, 1 and 1, 2 and 2, 3 and 3, 4 and 4. Elements are identical in both the sets. So in this case, I can say that these two elements are equal sets. I can say A is equal to B. These two elements are equal and I can say A is equal to B. Simple thing, right? Okay. Next one. People, in sets, when if you go through your textbook, CBS or any board, so representation of sets, operations like union, intersections are there. There is also the concept of Venn diagrams that we will be covering in the next coming class, not today. Okay, Venn diagrams will be taught in the next class. Today, without Venn diagrams, we are going to do majority of all the operations. In the next class, using Venn diagrams, once again, we will see that those operations. Okay, right. Diagrams. It is a diagram. It's very good. You will understand that very easily. Okay. Next. Let A be the set of prime numbers less than 6 and P be the set of prime factors of 30. It is not factors, it is a prime factors. That means the factors which are prime numbers. Let A be the set of prime numbers less than 6. So less than 6 means, can I start with 1? Can I start with 1? No. Why? 1 is neither prime nor composite. So I need to start with 2. Yes, 2 is a prime number less than 6. 3 is a prime number less than 6. 5 is a prime number less than 6. Why not 4? 4 is not a prime number. 4 is a composite number. And next, P is a set of prime factors of 30. P is a set of prime factors of 30. So what are that? Prime factors of 30. For example, first let us try to write all the factors of 30. Okay. So I can write 1 into 30, right? 2 into 15. 3 into 10, 4, no, 5 into 6, right? Anything else? 1 into 30, 2 into 15, 3 into 10, 4 into 5 into, okay. So you're having 8 numbers in that, 8 factors, but out of that, what are the prime numbers? Out of that, what are the prime numbers? If you carefully observe, 1 is neither prime nor composite. Don't include that, don't get confused. Okay. So the number 2, the number 3, the number 5, 6 is not prime, 10 is not prime, 15 is not prime, 30 is not prime. So it is 2, 3, 5. So carefully observe in this both sets A and B, although the questions are different, but the final answers are same, identical, exactly identical. So in this case, I can say that A is equal to P. Yes, they are equal sets. They are equal sets. Okay, understood. So let's move forward for the next question. Next concept. What is that? Which of the following pairs of sets are equal? Justify your answers. Okay. So please do that quickly. I'll have a glass of water and I'll come. Quick, very quick. Alright, so tell me what is the answer about x and y. Are they equal or not equal? So x is set of letters in alloy. So x I can write as alloy. That means A, L. No need to write one more L. No need to write one more L, right? So O and Y. So these are the elements in set X. What about set Y? Set of letters in loyal, L, O, Y, A, L. So see that. So Y will be L, O, Y, A. L is again repeated. Leave it. So are these two same? A is there, L is there, O is there, Y is there. So all four elements in both the sets are the same. So yes, I can say that the first set are equal sets. So the next one, so I'm leaving that for you. N square less than or equal to 4. So see what are all the numbers that satisfy that. And x square minus 3x plus 2 equal to 0. So see what are the answers that satisfy that. Okay. And comment your answers in the comment section. I will definitely look into that and I'll get back to you if you have done any mistake along with your name. People, next coming classes, I'll be taking those. Okay. Don't worry about that. Next. A set is said to be a subset of set B. People, now we are going to discuss about subsets. So what is subsets, right? Sub means a part of the main set. A part of the main set is subset. Okay. So A is said to be a subset of set B if every element of A, is also an element of B, right? So full stop, and we denote that with that symbol. Okay, something like this one, right? This one, A subset of B. A subset of B. We read that as A subset of B. So when I say A subset of B, what happens? Which set is small? Which set is big? Every element of A is also an element of B. That means A is small. A is a small set. If I want to represent like this using a diagram, okay. So let's say I'm representing the set as some circle, okay. If that is set A is a small part of the bigger set B. So I will have the bigger set B here. This is A and this bigger one is B. I can say every element of A is also an element of B. You can see that. Every element of A is also an element of B, right? So in that cases, we say A is subset of B. And then if A is subset of B, okay, and A not equal to B. Why not equal? Can they be equal? When I'm talking about subset, can they be equal? Yes, they can be equal. Why not? They can be equal. So if I have set A is this one, set B is also the same set, set B is also the same set, I can say every element of A is inside B, right? Every element of A is inside the set B also. So they can also be equal. So don't forget that point. When I say subset, even that equal set will also come into that. Okay. And now there is a special clause here. If A is subset of B and A is not equal to B. Okay. A is not equal to B. Then we say that A has a proper subset of B. It is subset only, but inside subset again, we are mentioning whether it is equal or not. So when it is not equal, we say it is a proper subset. Okay. And B is called superset of A. B is called superset. When A is small, B is bigger set. So this bigger set is called superset. Bigger set is called superset. Here B is called superset. Okay. Subset is a small one. Superset is a bigger one. Right? Empty set is a subset of every set. This is very, 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 very important point, and you always get confused with that. Because you forget about that. When you are trying to write down subset, I told you every element of A should be an element of B. And when I say empty set, when you say empty set itself is no element, then how can that be possible? That's your question. Right, people? See, it's like empty set means no element, right? When I'm talking about no element is also part of bigger set. right? No element is also part of the biggest. I'm not taking any particular value here. I'm not any particular value here, but emptiness is there in that, right? So when I talk about, for example, I talk about a set of A equal to 1, comma 2. Okay, careful observe. I want to write down all the subsets of this. I need to write all the subsets of A, subsets in small parts of that, as well as equal set, as well as empty set. Okay, people, this is one more ambiguous thing that many of them, even you, even me, still now will argue about this. Still, we don't have a solid proof for that to say empty set is a subset of every set. Even if I'm saying now, there are people in the comment section asking me again, sir, how empty set is a subset? Definitely you'll be asking, because we don't have a solid proof for that. It's always ambiguous that whether it is yes or no, but yes, empty set should also be included in the subset of every set. So in this set A 1, comma 2, I need to find all the subsets. Okay, all the small sets here. So I'm writing all the subsets here. People, we will look into this concept again later at a later stage, but don't worry, let's take a small example here. Okay, so when I talk about subsets, I can just mention the number 1. I can just mention the number 1, that is one set, which is small set out of that big 1, comma 2. Same way, the set 2, I can also write the set 2. Set 2 is also small set inside that. As well as I can also write set of 1, comma 2. As well as I can also write set of 1, comma 2. That is also a set in the bigger set. Right? As well as, see, those are equal. I told you equal set can also be a subset. So that is one point you may miss when you're writing the subsets. Okay, see, these are things that many of you do mistakes. I've seen a lot of batches in my previous classes. Even after saying that the equal set should also be included in subset, they forget about that. They just write the small parts. Okay, people. As well as this point, empty set is also a subset. So even empty set should also be included. Empty set, set 1, set 2, set 1, comma 2. Empty set, or you can write this as 5. Okay, both of them are same. Empty set or 5, right? So these are subsets. These are subsets. Okay, there are 2 elements. We got 1, 2, 3, 4 subsets. Okay, there is a formula for that to find how many number of subsets. So that is up to you. Like, work on that. Take 3 elements, write on all the subsets. Take 4 elements, write on all the subsets, and see that it follows a particular pattern to find the number of subsets. Okay, we'll take that in the coming classes, people. So next one, okay, so A equal to 1, 2, 3 and B is equal to 1, 2, 3, 4. Is A proper subset of B? 1, 2, 3 is there. 1, 2, 3, 4. So 1, 2, 3 is a part of the bigger set B. Sorry. 1, 2, 3 is a part of the bigger set 1, 2, 3, 4, right? So, and these are not equal. These are not equal if you carefully observe. So I can say that yes, A is a subset of B. A is a subset of B, right? Okay, so let's move forward for the next one. Write all the subsets of A, 1, 2, 3. Once again, the same thing I'm telling you. Before we just took 1, comma 2. Now we're taking 1, 2, 3. Now we're taking 3 elements. Okay, let's try to understand what are the total number of subsets. So based on that logic, you can easily try to find some easy formula to find number of subsets. Okay, right. So A is equal to 1, 2, 3, right? So I will first list down only set of 1, 1 elements each. So set 1 is one set 2, and set 3. So these are 3 small sets inside that big set. Are you understanding? Next, I'm now taking 2 elements together. I'm now taking 2 elements together. 1, comma 2 is again a small part of that. Next, 2, comma 3. Next, 3, comma 4. Not 3, comma 4, sorry, 1, comma 3. 1, comma 3. You can write 3, comma 1, okay? Order does not matter. You can write as 3, comma 2. You can write as 2, comma 1. Order does not matter. Right? And The last one is a complete set itself, that is 1, 2, 3, and people stop here. People stop here writing all the sets, all subsets, they are done. No. You still missed one set, and that is where you miss all your marks. People, that is nothing but empty set 5. Yes, 5 should always be included. Whenever you're writing subsets, don't forget that. Unless and until it is mentioned in the question, something like write down all the non-empty subsets. Sometimes the question will be given as write down all the non-empty subsets. When it is asked non-empty, you should not include this, because that is an empty. It is by default asked in the question. Then you should be very careful. But if it is asked list all subsets, you need to write even 5 also. Don't get confused. Okay, right, people. I hope you are all understanding. And students, every teacher, every lecturer has his own style and as well as own pace, fast or slow in the class, right? So go through the recordings. I mean, go through the YouTube or Physics Wall app classes, okay, and give your feedback, students. Whether you're finding this class too fast, or is it okay, or too slow that I need to increase the speed, or level of questions. I know that these level of questions are very basic, but trust me, as we move forward, the level of questions will definitely increase, right? Slowly, you will reach to the applications of JEE. I'm not taking any JEE questions here. I don't want to trouble you with the very first class, and I don't want to make you demotivated. People, demotivation is the biggest loss that you will ever have if you are in that stage. Okay, that should not happen. You should get self-motivated all the time. You should always get self-motivated, not by seeing some other success. People, that is again not correct. Get self-motivated by seeing your own progress. See what you're today. For example, today you are able to do 10 questions out of, let's 30 questions. You're taking some assignment, out of 10 you got 30. So make yourself self-motivated that tomorrow you need to do 11 questions. The next day you can do 12 questions, right? So that is how you can increase your motivation as well as the ability to do all the questions. Okay, slowly, gradually you can do that, people. Don't worry, don't hurry up in doing, okay? And one more point I always tell for my students, whenever you have a question paper, let's say you have 30 questions, don't be in a hurry to do all the questions. Don't be in a hurry to attempt all the questions. No. Be peaceful, take some time. Just slowly one after the other, write on. This is you're not writing JEE mains now, right? So take your time, no worries. Analyze yourself how many questions you're doing. 10 questions or 15 questions you're doing for 1 hour. Increase that. You yourself analyze yourself and take the progress. Bring the progress, okay? And people, if you have any doubts in anything, not only in subject, anything, just let me know that. I will take those and I'll give you the solution in the next coming classes, okay? So the next concept we are going to move forward is singleton set. The name itself says that. Singleton, that means it is having only one element. If a set A has only one element, we call it a singleton set. Okay, just let's say A is equal to just the element 1. Just the element 1, then it is called a singleton set. Just the element, let's say just the element small b, that is a single set. Singleton. Singleton set means it has only one element. So even prime number, I'm asking you, somewhere else also we got that. Even prime number, can you tell me what are all the even primes you're having? When I say all the even primes, again you might get confused. So how many even primes are there? Students, we only have only one even prime, so that is the number 2. So this particular set number 2, even prime, is again a singleton set. Alright, people, so don't get confused, students. Okay, don't worry, people. So let A is equal to A, E, I, O, U, all the vowels, you can say that. And B is equal to A, B, C, D is a subset of B. Is A subset? I told you what is subset. Subset is a small part inside the bigger set. Small set inside the bigger set, right? So now, A is okay, but what about E, people? E is not there. E is not there in B. So it is enough that we can say that A is not a subset of B. E is there which is not there, I is there which is not there in B, O is there which is not there. Okay, just one element, we can't do anything with that. The entire set A should be inside the set B, then only we can say it is a subset. Right, people, I always take lots and lots of applications in the class. I deal only half of them in the class, and I give you the rest as a homework, so that as soon as I teach you that, as soon as I give you the question, at that particular time only you solve for that. Don't again wait till the end of the lecture and at that time you again take 1 or 2 hours time solve for that. No. As soon as I give the question, you will start working on that. Okay, you will start working on that. Then only you can do that. Okay, at very fast pace. You should not waste time, students. Time is very crucial. Okay. So the next one, which is a very important concept, that is called intervals. Okay. What is this interval? People, for example, I want to write some range of numbers. Let's say I want to write the numbers between 1 to 10. All the natural numbers, let's say. I want to write all the numbers between 1 to 10. So, I need to have some interval. I need to have more information. Whether I can include 1 or whether I can include 10. 1 is included, 10 is not included. Okay, 1 is not included, 10 is included. So there are different combinations when I talk about I want to represent some set of numbers. So for that particular interval, particular ranges, particular cases, I need to represent that using intervals. Okay, so we have two kinds. One is open interval, one is closed interval. We will look into one by one. Okay. So, students, careful observe. I'm not going to give you any definition here to write what is open interval, what is closed interval. No, it is just a mathematical explanation. I'm not going to give you any particular definitions for that. Okay, so don't get confused. If there is no definition, many of them think that it's not important. It's very important. The thing is, I want to explain that with case to case, not giving a single definition for everything. Okay. Open interval. What is open interval? For example, people, I write an interval like this: 1 less than x less than 5. 1 less than x less than 5. So what I'm going to do here, and I say x is a real number. People, R is for real number. What is a real number? People, what is a real number? Real number means everything: natural numbers, whole numbers, integers, rational, irrational, everything will come. Okay, so you shouldn't leave any value between them. When I write 1 less than x less than 5, I need to consider the numbers between 1 and 5, but not only. What should I do with 1 and 5? What should I do with 1 and 5? Can I include 1 and 5? No, because there is less than. If in case there is less than or equal to, then okay, we'll try to that. Okay, but here we only have less than. So, students, what I want to do here, I will write the set as 1 to 5. 1 to 5, that's okay. But and to keep something to mention that I shouldn't include 1 as well as I shouldn't include 5. So this particular case is where we are not including the end values. We are not including the end values. That is called open interval. And open interval, we can write it as A belongs to 1, 5 small brackets. People, these are called small brackets, or we say open brackets or open braces. Okay, open brackets. So when I write like this 1, 5, that means 1 and 5 both are not included. Okay, 1 and 5 are not included. People, don't get confused. Okay, there are 3 or 4 cases inside this. Careful, 1 and 5 are not included. So if I want to represent the same thing on a number line, I can start from 1, I can start with 5, but 1 and 5 should not be included. So the numbers where I am not including, I will keep a hollow circle like this. Listen once again, people, listen and learn. Where I'm not including, I will keep a hollow circle, and I start from that point, go till 5, and 5 is not again included. Whenever I'm not including the numbers, I keep this type of hollow numbers, hollow circles. So whenever I see hollow circles, I can say that 1 and 5 are not included. Understood, people, what is open interval? Clear? It's very simple. When we are not having equalities, that comes under open interval. In open intervals, we should not include the ending numbers. Okay, all the numbers inside that can be included. So we can write a belongs to 1, 5, or here it is x. So we can write, one second, let me erase that. Right. Okay, so you can write x belongs to 1, 5. X belongs to 1, 5, right? Okay. So now as I discussed open interval, so now you may ask me, sir, then what is the other interval where 1 and 5 are included? You may ask me the next one where 1 and 5 included. So that particular thing is called closed interval. People, more about these intervals. So you'll be learning chapter by chapter. Whenever we have applications, whenever we want to write the final answers, we will again be using these intervals. Okay, it's very important. So now I'm talking about closed intervals. So now if I have a statement like this, if I have a set like this, okay, I have a is equal to x such that, okay, x such that x is a number satisfying 1 less than or equal to x less than or equal to 5, right? And x is a real number. 1 less than or equal to x less than or equal to 5. So what I'm doing now, 1 and 5 should also be included. 1 and 5 should also be included, right? So in that cases, people, see what we'll write. So x belongs to again the same 1, 5. But now I need to mention that 1 and 5 can be included. So that's the case where I keep square brackets like this. That's the place where I keep a square brackets like this. Square brackets represents that we can include 1 and 5 as well as all the numbers between them. Okay. So in that case, as careful as see, if I have a number line, if I have the number 1, if I have the number 5, I want to include 1 and 5 as well. So starting with 1, I keep a dotted or completely shaded circle like this. I start from 1, go till 5, and as I'm including 5 also, even 5 should also be closed. So this particular brackets, okay, are called closed brackets. People, so when I dictate the question sometimes, okay, when you're listening to any lecture, we say closed 1 and open 5, closed 1, closed 5, like that. So the closed and open, you should be very careful that this for closed, you should always use the square brackets, the big brackets, and for open, you should always use the small brackets. Okay, so that's the difference. And in some questions, we may mix these two. That means we may mix like this. See here, if I may write 1 to 5 open. So what happens in this case? 1 can be included, 5 should not be included. 1 should be included, 5 should not be included. It is closed at 1 and open at 5. Sometimes we may deal like this, 1 to 5 closed. So 1 should not be, 5 should be included. 1 should not be included and 5 should be included, right? You understood that? So these are intervals. Okay, we discussed open interval and we discussed closed interval. So very simple concepts. People, I hope you're all understanding. But once again, please comment in the comment section if you have any doubts. Don't worry about that. Okay, I'm here to teach everything. I'm here to solve all your queries. Okay, so write the following as intervals. The same thing, x belongs to r minus 4 less than x less than or equal to 7. 4 is not included. That means 4 is open. So 4 is open. Minus 4 is open. So not 4, minus 4. And 6, there is an equality here. So 6 should be included. So 6 included like this, minus 4 comma 6, right? People, it's a very, very, very simple thing, people. Nothing to worry about that. Once again, minus 2 is not, minus 12 is not included. Minus 10 is also not included. So minus 12 comma minus 10. Both are open. Okay. You need to write x belongs to, x belongs to. This is also x belongs to. 0 is included, 7 is not included. So x belongs to, 0 is closed, 7 is open. Right? Then last one you can try yourself. Both are equals. That means both ways you need to include or close. Right? So simple concept, people. See, why people get confused is they lack in the proper basics. If you are perfect with the basics, you will never do mistake in these type of simple questions. In very big questions, although like you may do errors in mathematical calculations, but silly concepts or small concepts, you should never do mistakes. Okay. Right. Next, write the following intervals in set builder form. Now it is in the reverse format. Set builder, I will explain you. Let's say the first and third one. The remaining you can do it later. Okay, on yourself. Set builder form minus 3 comma 0. So I can write that A is equal to x such that x belongs to real numbers. X belongs to real numbers. You can write that at the end also, no problem. Okay. And x is starting from minus 3 to 0, but both are not included. So I can write minus 3 less than x less than 0. Minus 3 less than x less than 0. And what is the next one? Minus 23 comma 5. Okay, so 6 comma 12. So this is A is equal to, again, x such that x belongs to R. And 6 should not be included. So 6 less than x less than 12 should be included. It is a closed interval. So less than or equal to 12. 6 less than x less than or equal to 12. Clear? Right. So what is the next one we are having? Next one, people. The set containing all objects or elements and of which all other sets and subsets is called universal set. Universal set. People, what is universal? Universal means the entire thing, right? Whatever we did, whatever the solar system, everything we include as universe. The same thing. I can say universal set is the mother of all the sets. It is the biggest of all the sets. Again, it depends on, again, case to case. Universal set is not just one set that you can define everywhere. Okay, it is from case to case. In that particular question, the set which consists of all the elements required for that is called the universal set. I'll give you examples, don't worry. Okay, the set containing all objects or elements and of which all other sets are subsets, it is denoted by universal set U. This is U. This U is used to represent universal set. Okay, simple thing. Universal set is the mother of all the sets. Okay, so we have a small example here. Given the sets A is equal to 1, 3, 5 and B is equal to 2, 4, 6 and C is equal to 0, 2, 4, 6, 8, which of the following may be considered as universal set for all the three sets? I told you, universal set, like it varies from question to question, set to set. So here we have three sets, 1, 3, 5, 2, 4, 6, 0, 2, 4, 6, 8. Now, I need to consider one single set which consists of all these elements. It may have extra elements as well, but these three elements should definitely be inside that. Okay. So see, if I go for the first option, 0, 1, 2, 3, 4, 5, 6. No, 0 is okay, 1, 2, 3 is okay, 4, 5, 6, but what about 8? 8 is not included, so that is wrong. Second and 5, that is wrong. You should have all the elements. Okay, this is 5 people. In some font, it may come like that, it may appear like that. And next one, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. Okay, so 1 is there, 3 is there, 5, 2, 4, 6, and 0, 2, 4, 6, 8. All the numbers are there here. All the numbers are here, right? Next one. See, although it starts from 1, 2, 3, 4, 5, 6, 7, 8, it is not having 0. Okay, so that is wrong here. So option 3 will be the correct answer. It has all the elements of all the sets. All the elements of all the sets. Okay. So moving forward for the next question. Right. So A is equal to 1, 2, element 3 and 4. This complete thing is one particular element. Okay. Comma 5. Which of the following statements are incorrect and why? Which of the following statements are incorrect and why? Okay. So see people. 3, 4 people. 3, 4 students are careful observe. For example, the same thing. Forget about that 3, 4. 1, 2, 5 is there. 1, 2, 5 is there. I can say 1 is an element in A. So 1 belongs to A, correct? 1 belongs to A. 2 belongs to A. 3 belongs to A. People, these are elements. Not 3, here it is 5. Okay. 5 belongs to A. Same way, 3, 4 is also one element. Okay. So same way, I can say set 3, 4 belongs to A. Set 3, 4 belongs to A, right? So your second option is correct. What about the first option? People, this symbol is used for subset. See, here if you want to write the subset, set 1 is a subset. Set 2 is a subset. Set 5 is a subset. Set 1, set 2, set 5, set 1, 2, 2, 5, 1, 5. In that, set of this particular term, set of this particular element, that is 3, 4, is a subset. That is also one subset. So, 3, 4 is subset of A is wrong. We need to have double brackets. You need to have double braces. Why? People, the element itself is having braces, and for subset you should have again one more braces. So, 2 set of braces should come, right? So, 3, 4 subset of A is wrong. And set 3, 4 is subset of A, that is correct. Set 3, 4, so that is subset of A, that is correct. 1 belongs to A, correct. 1 is subset of A, wrong. Again I told you subset means it should always be inside braces. Subset means it should always be inside the braces. Here the braces are not, the brackets are not there. So this is again wrong. Okay, right people? Don't get confused. Once again, if you're confused, once again, listen to what I said. 3, 4 is one element including the brackets. So that particular brackets belongs to is correct. Keep one more brackets, that is a subset of A, that is correct. Okay, right, next one. So the same thing you can try that people. A equal to 1, 2, 3, 4, 5. So you still have some examples on that. Okay, you can try that on yourself. Okay, 5 belongs to A. Is 5 an element inside that? No. 5 is not an element, people. But yes, 5 is a subset of A. I told you, empty set is always a subset. That is correct. So think about the ninth one also in that way. Okay, that is a set of an element 5. The meaning of this is set of an element 5. We should be very careful with that. Next, the most important thing, that is operations on set. What do you mean by operations? Are you going to do some kind of medical operations? No, people. Operations means like addition, subtraction, what we do for the normal numbers. So some applications are also there for sets, right? So in that, the first one we're going to discuss is a union of sets. People, the most important concept for the day, I'm telling you, union of sets. Okay. What are we going to do in this union? People, union, the name itself says union means we need to merge. You need to combine them, right? So that is union, right? So here, let A and B be 2 sets. So we are defining union for 2 sets. The same thing will also hold for 3 sets, 4 sets, any number of sets. The union of A and B is a set which consists of all the elements of A and all the elements of B. All the elements of A as well as all the elements of B, right? The common elements being taken only once. If there are common elements in both A and B, it is enough to consider it only once. Okay, and the symbol U, people, it's not U, not the alphabet U. Okay, but some kind of symbol like that. Okay, is used to denote the union. Symbolically, we write A union B. This one A U B, and usually it is read as A union B. So now this is the point you may get confused with the U kind of symbol that you used for universal set. People, that U is different from this one, okay? For universal set, it is like the capital U only, okay, whatever alphabet is there, okay? But for this is kind of like bold kind of thing, okay? A union B. Don't get confused. And whenever we say universal set, I told you sets are represented capital letters. So capital U, the big U, will always represent universal set. So that is one way you can find the difference between these two, okay? So A union B means we need to mention, we need to include all the elements of X which are there in A as well as which are there in B. X belongs to A or X belongs to B. It can be in any one of that. No need to have the same element in both the sets. Okay, I'll give you one example. For example, I have A is equal to 1, 2, 3. B is equal to 3, 4, 5. So I want to write A union B. A union B, I need to list out all the numbers of A and B, all. But if there is any number repeated, you should only include once. No need to write that multiple times, okay? So 1, 2, 3, 1, 2, 3. 3 is already included, no need to include that again. So 4, 5. So now clearly see here, we need to include an element X which is there in either A or B. Either A or B, okay? So 1, 2, 3 are coming from A. 4 and 5, the remaining elements will come from B. So A or B, no need to include, no need to say that the particular element should be there in both A and B. No. Even if it is there in one set, include that. Okay. So the next one. So we have few properties of operations of sets. What is that? First one, A union B is equal to B union A. A union B is equal to B union A. It is commutative law. What is the meaning of that? You take two sets, find A and B union, or find B and A union, B first and A second. The order does not matter. Okay, so both of them are equal. Okay, you take any set you want. Next one, associative law. People, the proofs of all this we can go later using Venn diagrams. Okay, so after coming to Venn diagrams, it will be very easy. But now if you want to prove them, just take some examples and you can move accordingly. Okay, next one, A union B union C is equal to A union B union C. That means when you're trying to find the union of three sets, whatever order you follow, you first find A union B, then find union with C, or find B union C and find union with A. Whatever it is, you will get the same answer. That is called associative law. And the next one, A union phi is equal to A. A union phi empty set. The set A and an empty set, if you join, you will completely get again a set A only. No extra elements will be added because it is an empty set. Right? In the same way, A union A is equal to A. You club A and A. You join A and A. What will you get? The same elements again. The same set of A will get again. Okay? So that is called idempotent law. Yes, these laws you need to remember. This is called idempotent law. And the next one, this is a universal set. Universal set means entire set. So the entire set, big set, union, a small set inside that, okay, is always again the complete set. You take like this, okay. So let us consider this as a universal set, the big box. Universal set. And this particular set as A. So I want to club these two, I want to join, I want to find the union of these two. So when you're trying to find the union, you will again get the same universal set back, the entire universal set back. Right? Okay. So after union, we are going to discuss, okay, we have a question, and after that we are going to have intersection of sets, okay. So we have A is equal to 2, 4, 6, 8 and B is equal to 6, 8, 10, 12. Find A union B. Union, I just told you that you need to include all the elements of A and B. So A union B will give you 2, 4, 6, 8, 10 and 12. 6, 8 are already included once. No need to include that again and again. Okay. So 2, 4, 6, 8, 10 and 12. That is A union B. Very simple question. So let's move for the next one. That is intersection of sets. People, I know that today I have taken a lot of concepts. Okay, because students, if you are clear with the basics, then the coming classes we can go for more applications. All my sessions will have a lot of applications, people. Okay, so that's the reason even I'm covering the basics at a bit fast level. Revise once again if you have any particular doubt. Get it clarified before the next class, because we're going to take a lot of applications in the coming classes. Okay, right. Next, the intersections of set A and B. But what do you mean by intersection? So intersection means what are all the common elements between A and B. Only the common elements should be taken, not all the elements. Only common elements should be taken. Okay, the symbol, okay, this kind of reverse N kind of thing, this symbol is used for intersection, denotes the intersection, and we read that as A intersection B. We read that as A intersection B, and the elements should belong to both A and B. The elements should belong to both A and B. Okay, so we can write like this. So X, such that X belongs to A and X belongs to B. And if you compare for union, you're getting OR in that case. But in this case, it is AND. X belongs to A and X belongs to B. Right? And if A and B are two sets such that A intersection B equal to 5, people, that means, what do you mean by A intersection B is 5? That means there are no common elements between A and B. For example, I have A is equal to 1, 2, and let's say B is equal to 3, 4. Tell me that 1, 2 and 3, 4, what are the elements common between A and B? What are the elements common between A and B? No elements, right? So in this case, what happens? A intersection B, if you find, you will not get any elements inside that. So when we are having A intersection B as a 5, then we call those type of sets as disjoint sets. We call those type of sets as disjoint sets. There are no common elements between A and B. Okay, so the next one, we have few more properties of intersection, right? So A intersection B is equal to B intersection A. That means when you have two sets A and B, if you're trying to find A intersection with B, common elements, or B intersection with A, as both of them says the same thing, that means the common elements between A and B, both of them will be equal. That means we can say the intersection of sets is following commutative law. The same kind of thing we also discussed for union of sets. Those are two different formulas, not the same, people. Okay. Next, for associative law, we are considering three sets: A intersection B intersection with C, and A intersection B intersection C. That is called associative law. Take three sets. Okay, just take A is equal to 1, 2, 3. B is equal to 2, 3, 4. And C is equal to 3, 4, 5. Just for example. Okay. So find what is A intersection B, make it intersection with C, or find B intersection C, make it intersection with A. So everything will give you the same answer. Okay. So next one, phi intersection A. What do you mean by that? Phi is an empty set. That means it has no elements, and we have a set A. No elements in set A. What is the common thing between these two? Definitely no common elements will come, because the other side we are having empty set. So how can you have common elements, right? So phi intersection A will be 5, and universal set intersection A is A. Universal set, let us try to represent this complete thing as universal set. Inside that we have a small set A. So what is the common between these two? The common elements between these two will be the set A. The common elements between these two will be the set A. Okay. And the next one, A intersection A is equal to A. That means set A and set A, we're trying to find the intersection. So both of them are the same. So we'll get the same set again. Okay, next one. Next one is important, that is a distributive law. The before is idempotent. Distributive law is important. You can see here A intersection B union C. A intersection B union C. That means we are trying to find union of B and C and then intersection with A. The same thing if you can distribute, that means A intersection B union A intersection with C. Okay, this is called distributive law. People, more of this we will again cover it with more and more examples. Don't worry about that. Okay, just try to remember it for now. And if you're confused, just take 3 examples A, B, C, 3 sets, and find this. Both LHS and RHS will be the same. So that is enough to say it is a proof, at least for now. But the major proof you can define after we discuss Venn diagrams. Okay, using diagrammatically, it will be very easy to prove all this. Okay, so coming classes we will look into that. And for today's class, I haven't taken any concepts of Venn diagrams because that's a big topic. If I start now, definitely will not go to end today. Okay, so half of it's not correct, so I took it forward to the next class. Okay, next. So let A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. B is 2, 3, 5, 7. Find A intersection B and hence show that A intersection B is equal to B. People, very simple thing. So we have 2 sets A and B. First, let's try to find what is A intersection B. A intersection B means what all the common elements between A and B. What all the common elements between A and B? Okay, so you can say 2 is common for both of them, 3 is common, 5 is common, and 7 is common for both the sets. So A intersection B will have 2, 3, 5, 7. If you carefully observe, A intersection B and the set B both are same. So it is enough to show that A intersection B is the same as set B. Nothing much. Straightforward question. Okay. Although the question looks very difficult, it's very easy. Right. So we have more questions, people. I'm going to do it, cover it, a few of them for today. The remaining you can take it as a homework. So given A is equal to 1, 2, 3, 4, B is equal to 3, 4, 5, 6, C equal to 5, 6, 7, 8. D is also given 7, 8, 9, 10. So find A union B. People, in union, I told you that in union, you need to include every element. Okay, so A union B will have 1, 2, 3, 4. 3, 4 is already included, and 5, 6. That's it. A union C. A union C. 1, 2, 3, 4, 5, 6, 7, 8. A and C clubbed. Same way you can find B union C. You can find B union D. You have 3 sets now. A union B union C. A, B, and C. Write down all the elements. It is equal to 1, 2, 3, 4, 5, 6, 7, 8. So that is A union B union C. Same way you can find A union B union D. Right? Easy things, people. So union means you need to club all the elements. Okay. And intersection means you need to just write down the common elements. Okay. Right. So we have intersections here. We'll look at a few examples here. A is 3, 5, 7, 9, 11. B is 7, 9, 11, 13. C is 11, 13, 15. And D is 15, 17. Then A intersection B. People, intersection I told you the common elements. Right. So A intersection B, common elements. What are common elements? 7, 9 is common for both of them. 7, 9 is common for both of them. Correct? B intersection C. B intersection C. What are common? 11, 13 are common for both of them. 11, 13. A intersection C intersection D. What are all the common elements between A, C, and D? 3, 5, 7, 9, 11. 11, 13, 15. Are there any common elements between these two? Between A and C, you can see 11 is common, but which is not there in D. People, A intersection C intersection D means all the elements which are common for all the 3 sets. So there is no element common between A, C, and D. So that will give you 5, or you can write as empty set. 5. Okay. So you can do the remaining questions, people. If you have any doubts, don't worry, just ask me in the next class. I'll definitely get back to you, okay? So I'll do one from here, sixth one, A intersection B union C. So first find B union C. So what is B union C? B union C is equal to 7, 9, 11, 13, 15. That is B union C. Now I want to find intersection with A. A is this one. B union C is this one. So what are the common elements between these two? What are the common elements between these two? 3 is not there, 5 is not there, 7 is common, 9 is common, 11 is common. Carefully see, 7, 9, 11, 7, 9, 11. So A intersection B union C will have all this 7, 9 and 11. Right? Okay. So the remaining things you can do it, people, on your own. Next one is a difference of sets, and probably we'll stop with this. We have one more concept, that is complement. Let's see if we have time, we will cover, or else we'll take that for the next class. Okay, no issues. So the next one is a difference of sets. So the difference of sets A and B in this order is a set of elements which belong to A but not B. A minus B, we write it as A minus B, we read it as A minus B. From A you need to delete the elements of B. From A you need to delete the elements of B, right? So the difference of the sets A and B is we need to include all the elements which are there in A but which are not in B. Okay, which are not in B. I'll give you an example, don't worry. Understand, elements should be there in A, but those particular elements which are there in A should not be in B. If there are any such elements, delete. Okay, so we'll take one example. So A is equal to 1, 2, 3, 4, 5, 6 and B is equal to 2, 4, 6, 8. Find A minus B and B minus A. I will do A minus B, you can do B minus A. Okay, so what is A minus B, people? In A minus B, I need to have all the elements of A, but whichever are also there in B, you need to delete them. See, 2 is here, right? So delete. 4 is here, delete. 6 is also in B, delete. So we are left with the remaining elements 1, 3, 5. Which all elements are deleted? The elements which are also there in B, because A minus B means the elements which are there in A but which are not there in B. Elements which are there in A but not there in B, so that elements we need to delete. Okay, so simple thing, people, A minus B. So similarly, you can also find B minus A. You can also find B minus A. Okay, so we have few more questions. A minus B, A minus C, A minus D, B minus A. You can do that, people. Okay, no worries. So in B minus A, so start with B and delete all the elements of A. I'm going to do this for you. Okay, the remaining you can do. So 4 is not there in A, so include. 8 is not there, include. 12 is here, so 12 is in A, so 12 should be deleted. And 16 is not there, you can include. Alright, and 20 is also not there, so you can include 20 as well. So that is a B minus A. From the set B, delete the elements which are also there in A. Which are also there in A. Simple. Okay. So what else we're having? So a few more questions, people. So the question is about disjoint sets. I told you what is disjoint. Disjoint means A intersection B is 5. No common elements. 2, 3, 4, 5, 3, 5. So 3 is common for these two. So are those disjoint? No, they are not disjoint. There should not be any common elements between A and B. AEIOU, A, B, C, D. A is common. So this is also not disjoint. Okay. So 2, 6, 10, 14, 3, 7, 11, 15. Yes. These are disjoint because there are no common elements between these two. Right? 2, 6, 10, 14. Next one. 2, 6, 10, 3, 7, 11. Here also, you don't have anything common. Even these are also disjoint sets. Okay. So simple thing. Let's move forward, people. So the last concept for the day, that is complement of a set. So with that, we will stop it for the day. Right, people? So what is complement of a set? Careful observe. When I have the bigger universal set, okay, let me represent like this, the bigger universal set. And let's say I have the set A. Now, I should include all the elements of universal set, but which are not there in A. Which are not there in A. U minus A. Let U be the universal set and A be the subset of U. Then the complement of A, people, which we represent with A prime or A dash like this, or we also represent with A complement like this, A power C. Complement of A is a set of all elements of U which are not the elements of A. Symbolically, we write A prime, A dash, to denote the complement of A with respect to U. Okay. So, people, A prime means from the universal set, whatever you are having, delete A, the remaining elements, whatever you will get, that comes under complement of a set. That comes under complement of a set. Okay. So let's see once again, a few more laws. Okay. People, so all these I'm going to cover once again in the next coming class, because we are to the end of the session. I don't want to drag it, or don't want to rush it, move forward, people. So complement of a set, the properties of that we are going to cover once again in the coming classes. Okay. So this will be the last of the class, people. So the remaining things, whatever we have in today's slides, so that we will cover in the next coming classes. Okay, people. So what is the summary that we have discussed today? We have discussed what is a set, right? The basic representation of a set, definition of a set. We discussed about the types of sets, and we discussed operations on sets, right? Like a union and intersection. We just started what is complement of set, that we are going to cover in the next coming class. Okay. So with that, we will end for the day, people. Thank you so much, and stay tuned to get the coming classes. Thank you.